So in this video, we're going to graph quadratic functions that are written in standard form. And remember, our standard form is like you see here, where it's written in y equals a times x squared plus bx plus c. So on the screen here, you see 6 different steps that we're just going to kind of go through kind of in order that allow us to create an accurate graph of a quadratic equation. So the first thing we're going to do is we're going to decide, does it open up or down, just by looking at the equation. We're then going to use the equation to find our axis of symmetry and our vertex algebraically. We're then going to take that vertex and we're going to put it into the middle of our table because our vertex is the middle of our graph, and then we're going to find points both above and below it. We're then going to graph the points that we've calculated onto the graph. And then we're going to end by finding the remaining key information of y-intercept, x-intercept, domain, and range. So here we notice we have a quadratic function written in standard form. And what I notice right off the bat is that I have an a value here that's equal to -1, a b value equal to 6, and a c value that is equal to -8. So to start off this whole process, I'm going to calculate my axis of symmetry and my vertex point. So my axis of symmetry is calculated by using x is equal to -b over 2 times a, which that's really a -6 divided by 2 times -1, which turns into -6 over -2. So my axis of symmetry is x is equal to 3. So I can take that information and I can go right to my graph, and I can actually draw a vertical line at x is equal to 3, and I expect that to be the middle of my graph. I expect that to be what cuts my parabola in half. So now I've got my axis of symmetry, so I'm going to move forward and I'm going to find my vertex point. Now remember, my vertex is a point, and it actually uses this x value here right from the axis of symmetry because it lies on the axis of symmetry. So we have an x value here of 3, and we need to calculate the y. So here I have y is equal to, I'm going to use my equation over here, so I'm going to give myself a little bit more room. So I have y is equal to a -1 times 3 squared plus 6 times 3 minus 8. So I start with my exponent, so I have -1 times 9 plus 6 times 3 minus 8. Well, then I do my multiplications, so I have -9 plus 18 minus 8. So then I combined addition and subtraction left to right. So here I get +9 minus 8, or 1. So I get y is 1. So if I now go to my graph, I go to x is 3, y is 1, and I plot the point. So I found my axis of symmetry and vertex. Now from here, I can actually make a prediction about whether my graph is going to open up or down. And if I look specifically at this a value here, I notice that a is equal to a -1. A being equal to a -1 tells me my graph should, once I start finding additional points, open up, down. So I now know that my graph will be opening up, down, and I know that it will be centered over here at the point x is 3, y is 1. So what I do next is I take my vertex point and I want to find points around it so I can get an accurate picture of what it looks like on the left side and the right side of our axis of symmetry. So I'm going to take this vertex point here and I'm going to put it into the middle of my table. And then I'm going to calculate some y values around it. So if I go to values that are slightly bigger than 3, I get x is 4 and x is 5. And if I calculate values smaller, I get x is 2 and x is 1. So now I'm just going to go through the process of calculating these points. So I'm going to start with x is equal to 5. So I have y is equal to a -1 times 5 squared plus 6 times 5 minus 8. So if I do my exponent first, I get negative 1 times 25 plus 6 times 5 minus 8. So that turns into a negative 25 plus 30 minus 8, which then from there becomes 5 minus 8, which becomes a negative 3. So I know that when x is 5, y is a negative 3. And then I can move forward and I can calculate my next point. So I have y is equal to a negative 1 times 4 squared plus 6 times 4 minus 8. And I do my exponent first, so negative 1 times 16 plus 24 minus 8. So I end up with negative 16 plus 24 minus 8, which becomes 8 minus 8, which is 0. So here we have when x is 4, y is 0. And I can go to my graph, and I can plot that point there. And then I calculate my next point. So I have y is equal to a negative 1 times 2 squared plus 6 times 2 minus 8. Well, I do my exponent, so negative 1 times 4 plus 6 times 2 minus 8. So I multiply, so I have a negative 4 plus 12 minus 8. Those together become 8 minus 8, or 0. So here I go to x is 2, y is 0. Then my final point here, I have y is equal to a negative 1 times 1 squared plus 6 times 1 minus 8. So here I have a negative 1 plus 6 minus 8. So that turns into a positive 5 minus 8, or negative 3. So I plot that point. X is 1, y is negative 3. So then from here I can see my parabola shape. So I'm going to graph it. And then from here I need to calculate other key components of my graph. So the first thing I need to find is my domain. I notice that my graph's going forever left and right. So my domain is simply all real numbers. My range has a highest value of 1, and then it goes down. So my range is y is less than or equal to 1. My x-intercepts I can clearly see on the graph. I can see I'm crossing the x-axis at 2, 0, and 4, 0. And then finally my y-intercepts I can't really super clearly see, but this is something that I can actually calculate. So I know that at my y-intercept my x value is equal to 0. So I'm going to calculate y when x is 0. So we have negative 1 times 0 squared plus 6 times 0 minus 8. Well, that becomes 0 plus 0 minus 8, which is simply negative 8. So my y-intercept is occurring right here. At x is 0, y is negative 8. So let's try a second equation here. I can see this is written in standard form, and I can easily identify my a, b, and c values. So I have a is equal to 2, b is equal to 4, and c is equal to a negative 6. So I start off this process by finding my axis of symmetry for the graph, so I can start to see where it's going to be centered. So I start with x is equal to negative b over 2 times a. So here I have a negative 4 over 2 times 2, which is negative 4 over 4, or x is equal to negative 1. So if I go over to my graph, I can draw my axis of symmetry and say this is where my graph is going to be centered. Then the second piece I look at is I look at the vertex point. And again, I know the vertex is a point, and I know that the x value in the axis of symmetry is shared by the vertex. So now I'm going to substitute that value into my equation and find the corresponding y value for that vertex. So I take y is equal to 2 times negative 1 squared plus 4 times negative 1 minus 6. So we start with our exponent there. So we have 2 times negative 1 squared is 1. So then I have plus 4 times negative 1 minus 6. Then I do all my multiplications. So I have 2 plus negative 4 minus 6. Well, those two added together give me a negative 2. Negative 2 minus 6 gives me a negative 8. So I can see from here that my vertex point is going to be at negative 1 comma negative 8. So I can see my vertex point there. Then from here, I want to make a judgment call on whether my graph is going to open up or down. And if I look here at my a value, I notice that my a value is positive. And because my a value is positive, I know it's going to be a normal parabola that looks like a U and opens up. So that's what I expect to see as I find additional points. Now as I go to add additional points, I'm going to take my vertex point and I'm going to plop it into the middle of my table. So here I have x is negative 1, y is negative 8, and I anticipate that that will be the middle of my graph and that the points around it will be symmetrical. So now I need to pick some x values around that. So I'm going to pick some x values that are bigger than negative 1, so I'm going to go up one integer to 0 and up another integer to 1. And then I'm going to go in reverse, so down to negative 2 and negative 3. So now I'm going to calculate these values for y that correspond with those points. So let's start with the first one of x is equal to 1. So I take y is equal to 2 times 1 squared plus 4 times 1 minus 6. Well, 1 squared is 1, so I can do that exponent first. Then I do my multiplication. So I have 2 plus 4 minus 6. So now we end up with 2 plus 4 is 6, so 6 minus 6 is 0. So we get the point x is 1, y is 0. So that's that point right there. I'm going to switch colors. So here I now have y is equal to, now we're going to do 0. So 2 times 0 squared plus 4 times 0 minus 6. Well, I get 2 times 0 plus 4 times 0 minus 6. So that's 0 plus 0 minus 6, which is just a negative 6. So I go to x is 0, y is negative 6. Then from here, y is equal to, now we're going to have x is negative 2, so 2 times negative 2 squared plus 4 times negative 2 minus 6. Exponent comes first, so it's 2 times 4. And we have plus 4 times that negative 2 minus 6. So now we do our multiplication. So we have 8 plus a negative 8 minus 6, which becomes 0 minus 6, which is a negative 6. So we go to x is negative 2, y is negative 6, so I can see it's symmetrical around there. And then I end with negative 3, so y equals 2 times negative 3 squared plus 4 times negative 3 minus 6. Exponent comes first, so it's 2 times 9 plus 4 times negative 3 minus 6. Now we do multiplication, so that's 18 plus a negative 12 minus 6. Well, that becomes 6 minus 6, which is 0. So we have x is negative 3, y is 0. So now we can take our points and graph them. And then the last thing we need to do here is identify our key information. So our domain, because we're going forever left and right, is all real numbers. Our range has a low point of -8 and then it goes up. So it's y is greater than or equal to a -8. Then from here, my y-intercept, I can see I'm crossing the y-axis at the point x is 0, y is -6, so it's right there. Then my x-intercepts are where I'm crossing the x-axis, and I have two of them. One of them is occurring at -3, 0, and the other one is occurring at 1, 0. Now this final graph here, I'm not going to do the entire thing, but I want to have a conversation about how we would start this particular problem. So here you'll notice that we only have two terms, and this is a situation where we need to be very careful. Remember that a is the coefficient of x squared, b is the coefficient of x, and c is just our constant value. So in order for us to start this process correctly, we have to identify a, b, and c correctly. So in this case, a is equal to a -2. Really hidden in here but not written is plus 0 times x. So what that means is my b value is really 0, and my c value is really equal to a -8. So be very, very careful. Without that b value in there, you have to figure out what's really going on with b. b is not a -8, but b is actually 0 because there's an implied 0x in between the x squared and the constant.